Hello friends, Ace Botany. Next episode. In this episode, we'll be discussing chapter number 13, Biodiversity and Conservation, second part. So for convenience, I will share the screen so we can proceed. I think the screen came so we can proceed. So what all things we'll be discussing in this episode? As usual, there'll be introduction, then pattern of biodiversity, latitudinal gradients, species area relationships, importance of species diversity to the ecosystem. After that, 5 theory question, 5 NEET model question with the key. So we can proceed as an introduction. See, based on the areas, based on the locations, how biodiversity varies. Because biodiversity is not constant throughout the world. How species area is related. And what is the importance of biodiversity to the ecosystem? That is what we'll be studying in this episode. So first we have to start with the heading, patterns of biodiversity. As I already told you, in this world, diversity of plants and animals not at all uniform. It varies. Various reasons are there. What are the reasons how it varies that we will be observing? First is latitudinal gradients. So before latitudinal gradient, we should know altitude. Altitude in the sense, high altitude means low diversity. Low altitude like plains, that is having high diversity. That is regarding altitude. Now latitude. High latitude, that is towards poles. That means low diversity. Low latitude, that is towards equator. That is having high diversity. So high latitude towards poles, 90-degree north latitude or north pole. 90 degrees south latitude, south pole. Arctic and Antarctic, North Pole and South Pole, diversity is very, very less. And they are in high latitude. Automatically, diversity is low. I think that idea you got, latitude, altitude, etc. Now we can proceed to page number 2. I mean, that is clear, first page, because that basic terms we should familiarize. Now, low latitude. Low latitude means close to equator between 23.5 degree north to 23.5 degrees south. This area often referred to as tropics. Now here, year-round warm weather, automatically diversity will be high. A map is shown there, so you can easily find where is the equator. Thus, we can easily say biodiversity is maximum in 23.5 degree north to 23.5 degrees south, latitudinal range. That is maximum biodiversity. Moderate biodiversity in temperate area and minimum or least diversity in Arctic region. I think idea clear. Now next is some important data regarding biodiversity. It is concerned with the NCERT reprint edition, March 24, page number 219, etc. It is given one question guarantee from this data. Data only, nothing to use brain or anything, simple data-based questions. Colombia, located near equator, has got or has nearly 1,400 species of birds. Well, when we come to New York at 41 degree north, has 105 species of birds. And when we reach into Greenland at 71 degree north, only 56 species of birds. So you can find diversity decrease. India, with much of its land area in tropical latitude, has more than 1,200 species of birds. So, a lot of popular questions. Now we can proceed to next page. Also, some important data are there. A forest in a tropical region like Ecuador has up to 10 times as many species of vascular plants as a forest of equal area in a temperate region like Midwest of USA. Largely, tropical Amazonian rainforest in South America has got greatest biodiversity on Earth. And it is home to more than, take care. Now a big data, as the following type question, 40,000 species of plants, 3,000 fishes, 1,300 birds, 427 mammals, 427 amphibians, 378 reptiles, 1,25,000 invertebrates. Popular questions. Direct NCERT, page number 219. And scientists estimate that in this rainforest, that might be at least, or there might be at least 2 million insect species waiting to be discovered and named. 2 million. It's also a popular question. I think idea clear up to this. Even though data, try to by heart or remember it. Exam-wise important. So automatically we may think, what is the speciality about tropics? Why biodiversity is rich in tropics? So for this, ecologists and evolutionary biologists suggest some views or various hypotheses. 3 views we can proceed according to NCERT. A or 1. Speciation is generally a function of time. So we should know what is speciation. Speciation means formation of a new species. How? Or why here? More species. Biodiversity more. Unlike temperate regions, subject to frequent glaciation. So we should know what is glaciation. I've given a photograph there and a definition given below it. Glaciation means formation, movement, and recession of glaciers. That means large ice masses that will affect landscape, ecology, and geology, etc. That is connected with the glaciation. Now the sentence is, unlike temperate regions subjected to frequent glaciation in the past, tropical latitudes have remained relatively undisturbed for millions of years, and thus had a long evolutionary time for species diversification. Now, second reason, tropical environments, unlike temperate ones, have relatively less season, means more constant and predictable environment. This environment can promote a greater species diversity due to niche specialization. Niche will be learning in ecology. After finishing this, we'll be entering into ecology. Now, third one. In tropics, more solar energy is available, leads to more productivity. And more productivity means it can lead to greater diversity indirectly. So 3 reasons NCERT says why more biodiversity in tropics. I think idea clear. We can proceed to next. That is 3 points important for theory and NEET exam. Now, next is species area relationship. It's another interesting area in this biodiversity. Many experiments done by many scientists. For us, concerned with NCERT, one famous scientist is Alexander von Humboldt, 1769 to 1859. He was a German naturalist, geographer, and he worked in or conducted this experiment in South American jungles. And in this, I just shown that a graph is important, and a formula also given. And a graph in a miniature form also given here. That is to show, normally when we solve the issue S equals CA raised to Z, we'll be getting rectangular hyperbola. And in logarithmic scale, it is a straight line. Next page will be explaining all this. The scientist is Alexander von Humboldt, idea, species area relationship, South American jungles. Now we can proceed to expanded form of the graph. Alexander von Humboldt observed that within a region, species richness will increase. How? When we increase the exploring area. But this increase will be up to a certain limit. Relationship between species richness and area for a wide variety of taxa, angiosperm, bats, birds, freshwater fishes, turns out to be a rectangular hyperbola. As I told you, this blue one is rectangular hyperbola. And when we convert it into logarithmic scale, relationship is becoming a straight line. Bottom, you can find red. And the equation for it is log S equals log C plus Z log A. So this equation S equals CA raised to Z converted into logarithmic form log S equals log C plus Z log A. Now value of Z lies in the range of 0.1 to 0.2 regardless of taxonomy group of or the region. That value somewhat common manner it exists. I think idea clear. Now, what are the terms concerned with the formula that we haven't discussed? S equals species richness, A equals area, Z is slope of the line, otherwise called regression coefficient, C is y-intercept. It's a popular question. Now we can proceed to next page. So when we start to discuss with the next page, importance of slope of regression Z in relationship between species area. See, it gives an indication that species richness will decrease when less area is explored. Z value stands for slope of regression of species area relation will lies between the range of 0.1 to 0.2 when small areas are analyzed. So when small areas are analyzed, value will be somewhat constant like 0.1 to 0.2. Typical example, plants in Britain, birds in California, mollusk in New York State, etc. Slope is amazingly similar compared to a small area. That may be the reason. But when we analyze very large area for species relationship like the entire continent, slope is much steeper. Z value is in the range of 0.6 to 1.2. Example, value is 1.15 for frugivorous. Frugivorous means fruit eating. Ecology question. So 1.15 for fruit eating birds and mammals in the tropical forest of different continents. So larger area explored, slope value is more steep, indicating faster increase in species richness with the area. I think idea clear. Now we can proceed to next page. Importance of species diversity to ecosystem. So naturally a question, does the number of species in a community really matter to the functioning of ecosystem? Number of species and functioning of community in a relation? Yes, definitely it is yes. So you may ask a reason. Reasons include, for that we should know how biodiversity works. Basically, three ways it works. One is it enhances productivity, stability, different or alternate pathway connected with the stability, etc. Then next is resilience. Resilience means come back to original condition. Similarly, health of ecosystem. So these all depends. And one by one, we have to expand further. So when we say stability, productivity, you are familiar. Stability. What is stability? So ecologists believe that communities with more species generally tend to be more stable than those with less species. What is stability for biological communities? For that, three basic aspects will be there for stability. One, it's a famous question in NCERT, productivity almost uniform in years. No variation, no much variation productivity per year. Resistant or resilient to occasional disturbances, natural or man-made. It is able to resist. Third is resistant to invasion by alien species, organism not seen previously there. When they come, it is able to resist. These three show stability features. So is there an experiment for it? Yes. That is our next area. Scientist is David Tillman. Experiment concerned with the stability. David Tillman conducted three aspects. One, long term. Two, ecosystem experiment. Three, with the outdoors. Give some clue for stability. Tillman found that plots with more species showed less year-to-year variation in total biomass. Increased diversity contribute to higher productivity. Again, a counter question will come. How is our quality of life affected if, say, instead of 20,000 species of ants, we have only 15,000 ants on Earth? So how it will be affected? So for this type of question, no direct answer for such naive questions, but again, some clues can be provided. And here, it is provided by a famous scientist, Paul Ehrlich. Experiment name is Ecosystem Health. And Paul Ehrlich is a Stanford ecologist. Theory name is rivet-popper hypothesis. In an airplane that is equivalent to ecosystem, all parts are joined together by thousands of rivets that is equivalent to species. If every passenger traveling in it starts popping a rivet to take home, each passenger, one rivet, causing a species to become extinct. So that rivet gone. So that species gone. Likewise, it may not affect flight safety. Likewise, when a species gone, proper functioning of the ecosystem may not be affected initially. But as more and more rivets, that is interesting thing. When more and more rivets are removed, the plane becomes dangerously weak over a period of time. Furthermore, which rivet is removed also critical. Loss of rivets on the wings that is equivalent to key species that drive major ecosystem functions is obviously a more serious threat to flight safety than loss of few rivets on the seats or window inside the plane. This is a line given by NCERT rivet popper hypothesis by Paul Ehrlich. Stability experiment by David Tillman. Two famous experiment, usual question. Then after that, 5 theory question, 5 NEET model question with the key. I think idea clear, so we can just revise what all things we learned in this second part of biodiversity and conservation. The exam point of view, important topics are here in this episode. 2 questions we can anticipate. Such a important area. As usual, introduction. What is biodiversity? Area, location, how it is connected, species, area, related, etc. Then pattern of biodiversity. That we start to explain high altitude, low altitude, high latitude, low latitude, poles, equator, that way. Then next is low latitude, where it lies. Then biodiversity maximum in 23.5 degree north to 23.5 degree south. Then moderate in temperate and minimum in Arctic region. Then 8 or 9 important data concerned with the NCERT is a famous question, usual question, we may ask the following type question. This way they can put it even. Again, last sentence, 2 million insect species waiting to be discovered. That also important. Then we entered into what is so special about tropics, biodiversity rich in tropics. 3 condition, that is speciation is a general function of time, connected with the glaciation, etc. Then tropical environment, almost constant. Then more energy available, so productivity more, connected with the speciation. Then species-area relationship, Alexander von Humboldt, 1769 to 1859. South American jungle, German naturalist and geographer. S equals C raised to Z, S species richness, A area, Z is slope of the line or regression coefficient, C is y-intercept. Then here it is rectangular hyperbola. In logarithmic scale, it is a straight line. An idea behind, that is value of Z lies in the range of 0.1 to 0.2 regardless of taxonomic group of the region. Then we discussed importance of slope of regression relationship between species area, 0.1 to 0.2, when small areas are analyzed. Plants in Britain, birds in California, mollusks in New York State. Slope is amazingly similar. But when we analyze big entire continent, very big area, that slope is much steeper. Z value 0.6 to 1.2. For fruit-eating birds, 1.15. And actually is large area explored, slope value is more steeper, indicating faster increase in species richness with area. Then importance of biodiversity to the ecosystem. It will be connected with the productivity, stability, then different pathways, resilience, etc. Then what is stability? Then what are the features of stability? 3 important items, stability. Then 2 famous scientists. First is stability concerned with David Tillman. Long-term ecosystem explained with the outdoors. And finally established that plots with more species show less year-to-year variation in total biomass. Increased diversity contribute to higher productivity. Again, confusion came, that is, if 20,000 species were originally there, suppose it become 50,000, any effect that is provided by ecosystem health by a scientist called Paul Ehrlich, Stanford ecologist, famous theory is rivet popper hypothesis. And airplane is ecosystem, rivets are species, some rivets removed, no much issue. Some species gone, no much issue. But there are certain rivets, like on the wing, or important rivets. Likewise, certain important species, when lost, it may affect ecosystem. That is how Stanford ecologist rivet popper hypothesis, ecosystem health. Then, as usual, 5 theory question, 5 NEET model question with the key. If you like this episode, please subscribe or like it, share it, comment on it. We can meet later. So, bye, take care, thank you.